Did you have a specific question with this one?
Very messy and confusing.
Yeah, I mean, I kind of like what you committed to here, which is, I really do like the columns and the color coding for all the different types. I think that's a great way to do this. What are we in? We're in B period, right? Sound good? So, put that there. There we go. It's nice. I like that. Did you have any problem identifying which one was which, or it just takes a little while?
Some of them, yeah, but it just took a while.
It takes a little while. I totally agree. It does take a little while. It's not that bad, but it just takes a while. And yes, it is a little longer at the beginning here. It's going to be a little redundant, but we need to get you up to speed with the basics before we get even more complicated. So on F, are they all real numbers?
Yeah.
Yeah, that's it. Yeah, they are all real numbers. Those are all. How do you know if a number is a real number?
If it's not imaginary.
Well, that's true. Yeah, that is one way. No, I like that. That's good. What? That's a rational number. How do you know something's a real number? If it lives on the real, it's called the real number line, right? I mean, it seems kind of silly because right now you haven't dealt with any numbers that don't live on the real number line. Are there numbers that live somewhere else? Yeah. So what happens when you start square rooting negative numbers? What times itself equals -4? Well, you had to come up with a different type of number to have that happen, because anything on the real number squared is either 0 or positive. A negative times a negative is a positive. A positive times a positive is a positive. So if I ask you what's the square root of -4, without knowing more or having new terminology, you can't go anywhere with that. Just before I forget here, I did put the answer key to the summer review homework in your week 1 folder, so you can take a look at that. I did it out and scanned it for you, so go do that. Does everybody have access to the book now? Is the book something you have access to? Too earth-shattering, but you need to know. So, hey, there's a really complicated thing. -6 plus -3. If you were actually going to do that out, you could just go straight to the answer. What would one thing be that maybe you would do before you wrote that out? What's like one intermediary thing you could write?
Get rid of the brackets.
Yeah, you could get rid of it. So if you wanted to do that, well, you could get rid of the brackets. -6 minus what? 3. And then what do you end up with? The only reason I bring this up is because the book presents this and then explains to you the super general way of like adding and subtracting numbers. And you need to be good consumers of information, especially math information in this class. Here's how they explain the general way of doing it. They say, to add two numbers with different signs, find the absolute values of the numbers and subtract the lesser absolute value from the greater. The sum has the same sign as the number with the greater absolute value. Does that make things clearer for you?
No.
I read that, I was like, wow, that's terrible, okay? Just because it's written down in a published book that all of you have access to doesn't mean it's going to be perfect. This is super general, which you can go back to, but in this case, if you understand how to add and subtract numbers, do you need to sit there and meditate on this and totally understand it? And it's okay. I'm okay with you ignoring that, okay? You can make that decision. If you're confused about it, come in and ask me. What about something like this? When you have a fraction, what's the main thing you need to do to this in order to make it play nicely with what you want to do with life? Yeah, Calvin. Oh, sorry, Nate.
Have a common denominator?
Exactly. Yeah, you need common denominators to add and subtract fractions. Now, the reason I bring this up, so you're going to have 5/6 plus 3/8. What's our common denominator going to be?
24.
Yeah, it'll be a least common denominator. Are there many other common denominators you could use? Yeah, absolutely. The idea here, the reason I bring this up now is A, it's important, but also because this stays the same. This rule, you need a common denominator to add or subtract fractions, no matter what the type of fraction is. You might have something called a rational function, which is going to be a polynomial over a polynomial, adding with a polynomial over a polynomial. To add those fractions, what do you still need? A common denominator. You have to have a common denominator no matter what. In this case, 24 is your happy least, what, LCD, least common denominator, I think is what you generally see. That's nice. What about the distance between points? How do you find the distance between, those are 2 points on the real number line. How do you find the distance between 2 points? What's the general way to do that? Yeah, Nate.
You can count the numbers.
You could count, absolutely. You absolutely could count. So in this case, if you counted it, what's the distance between 8 and -4? 12. If you weren't going to count and you wanted to do it more algebraically, what would you do?
You could add the numbers, but not with the negative.
Ah, okay, so you could add, but this case you can't really do that, right? Because if you add 8 and -4, you get 4. That's not the distance. So you can't. You could add in some cases, but not this case.
You take out the negative.
Take out the, yeah, so we need to be, let's try to come up with the operation that works best. Do you have an idea?
I was going to say maybe graph.
You could graph it. So we'll call this counting slash graphing, because it's kind of the same thing. Like there's a visually you could do it that way,
Yeah.
okay? But let's say you want to do it algebraically. What's the distance between 2 and 8?
6.
6. How did you get 6?
Because I know addition.
Algebraically. You didn't add 2 and 6. Subtracted, right?
Okay.
So if you subtract these, what's 8 minus negative 4? 12. But saying the distance between 8 and negative 4 is the same thing as saying the distance between negative 4 and 8. So what happens if I subtract it like this? What do I get? Negative 12. But distance is always positive. What do you do to 12 and negative 12 to get the proper answer? Absolute value. So, or you could do the absolute value of a minus b. Does it matter if you do that or this? No, it doesn't. And here's the trick. Why is that the case?
Because you're finding absolute value.
So it's always positive, but let me show you what we're talking about here. Another function if you go to, and see this insert space button right here? If you click this, you can then put as much space as you want into a document. So if I needed more space right there, just something for you guys to know how to do. So now there's more blank space. Kind of helpful. Look at this, everybody. If I have a minus b, and I want to compare it to, if I want to compare it to b minus a, what's the relationship between those two? What's 2 minus 5?
Negative 3.
What's 5 minus 2?
3.
What's 4 minus 6?
Negative 2.
What's 6 minus 4?
2.
What's the relationship? What's the, they're opposites, right. So a minus b is equal to the opposite of b minus a. But what happens if you take the absolute value of these things?
Same thing.
They end up being the same thing. So the idea is, this is true. A minus b is equal to the opposite of b minus a. But when you take the absolute value of two things that are just opposites, the absolute value of negative a and a is going to be a. So either way. So the point is, you don't always need to graph it or want to graph it. So what do you do instead? You subtract the two quantities and take the absolute value. Here's an idea that, or a concept that you've seen before. Reciprocal. The reciprocal of a non-zero number, a, is 1 over a. Why can't it be 0?
Because 0 over 1 doesn't exist.
1 over 0
1 over
doesn't.
0.
Yeah, 1 over 0. Is that what you're going to say? 1 over 0, it's undefined. You don't like dividing by 0. The world ends, black hole forms, and we're all very unhappy.
Yeah.
Right? Now, is reciprocal the same thing as opposite?
No.
Yeah, that's very important. Not the same as opposite. Sometimes you see them together because sometimes you need the opposite reciprocal. What's the opposite of a? Negative a. What's the reciprocal of a? 1 over a. The opposite reciprocal of a? Negative 1 over a. You see that you'll need opposite reciprocals, but the key here is just to make sure you don't do both unless you need to.
What can you do with the opposite reciprocal?
There's a lot of times you need, there are times when, for example, if you have a line, let's say you had a line y equals 3x plus 9. What's the slope of that line? 3 over 1. Anybody know what the perpendicular slope is? Nope.
No.
Negative 1 over 3. The opposite reciprocal slope are perpendicular.
Okay.
Two lines are perpendicular if their slope's product is negative 1. What's 1 over a times negative 1 over a? Sorry, what's 1 over a times negative a over 1? The reciprocal. Negative 1. The a's cancel, right? That's one example. Okay, so you see this. When you divide by a number, dividing by b is the same thing as putting it in the denominator. Dividing by b is the same thing as multiplying by. Dividing by b is the same thing as multiplying by. Reciprocal. When you divide by a over b, that's the same thing as multiplying by the reciprocal. Dividing is multiplying by the reciprocal, the related operation. So that's just what you need to do. So this is what I'd like you to do right now. Right now on your Surface, you can create a new tab like classwork for this day. Just right under your homework tab. Do these 3 simplifications right here. An answer to 103. What do you got, Nate?
I got negative 1 over 8/27.
1 and 8/27, so I think that's 35 over 27. I love the mixed fractions. Anybody got negative 35 over 27? Anyone? No? Well,
Negative 1.
I don't like mixed. No mixed fractions. I just said that out loud. Oh, don't make me sad.
Oh, I got that.
Don't
I'm
make me
sorry.
sad.
I did get that. I'm
Making
sorry,
me
Nate.
sad. What I mean by that is sometimes I'll see mixed fractions that look like this, like 2 and 3, 4. Is that 2 times 3/4 or 2 and 3/4?
Yours looks so much better than mine.
2 and 3/4. Well, who knows? Like definitively, it's unclear in certain circumstances. So rule is leave it as improper fractions. So in this case, Dividing by a fraction is the same thing as multiplying by the what?
Reciprocal.
Reciprocal. So you have 7 over 6 times negative 10 over 9, like this. So what do you end up with? Negative 70 over
54.
54, and that's equal to negative 35 over
27.
Leave it there. Done.
Good.
Again, on this one, flip it over first. 12 over 5 times negative 25 over 18. Before multiplying it out, you could, if you wanted to, you could do what? Cancel that and turn that into 5.
5 and 1.
Cancel this. Both of these are divisible by,
2 and 3.
well, they're divisible by 6.
6.
So this becomes 2 and 3. So this becomes 10 over 3. And on this last one, dividing by 2 is the same thing as multiplying by what? Dividing by 2 is the same thing as multiplying by?
No, 1/2.
1/2. So you cross that, that becomes 4, and you end up with negative 4 over 9. Negative 4 over 9. The base, exactly. So you got the base and the, what's the n called? The exponent. And whatever that number is, it has to be a natural number. What's the smallest natural number? 1. So that's the smallest it could be. Absolutely. Well, you could actually, you can put in, they put in 0, but can you raise something to the 0 power?
No.
You actually can.
Well, you can.
Math books lie to you for a long time for certain things until they have to explain them. Technically speaking, anybody know what a to the 0 is? It's really easy. It's actually 1. I can show that to you later, but anything to the 0 power is going to be 1. What? What? Mind blown. I'll show you later. We can come back. It's not super important right now. It's important that you know it's the base and the exponent. This is by far, right here, this is by far the most common mistake people make when it comes to exponents. Those two things, negative a to the n and in parentheses negative a to the n, are completely different. What do I mean? Negative 5 to the second power, what is that?
25.
Negative 25.
Oh.
That negative sign is completely separate from the square. Is the negative being squared there?
No, but you're doing
No, it's not. What about this? Negative, wait. What about negative 5 in parentheses squared? That is negative 5 times negative 5, which is 25. These are completely different. Don't make this mistake. This negative sign is not being raised to the power. This is negative 5. You can think of this right here. Another way to think about it, if it helps you. This is negative 1 times 5 squared. The negative 1 is not being squared. The negative 1 is just along for the ride.
Oh, so the 2 is only the
Acts on
exponents only act
what
on
it's touching. That this is only touching that 5.
Okay, but
Please don't make this mistake. You will, I can guarantee, because I do. You're cruising along, you forget. That negative sign is off by itself. You do the squaring, then you do the negative. What's another way to say this, the order of operations? What's that key thing you've learned before? PEMDAS, right. Why is this helpful? It's helpful because if you do it in a different order, can you end up with a totally different answer? Absolutely. Absolutely. So on this right here, what operation should we perform first? So what does that stand for? What's the P stand for, everybody?
parentheses.
Parentheses. And that's any grouping operation. Any grouping operation. And then E and M, exponents, multiplication. So which operation should we do first? In the it's not parentheses, it's absolute value, which is still a grouping. It's a grouping. So this becomes what? Well, it's negative 1 times 2, right? Plus 5 divided by 10. What is the absolute value of negative 1? So you have 10 divided by 5 plus 2 times 1. Now what operation do you do? Yeah, 10 over 5 plus 2. That's going to be 2 plus 2 is 4. What about this next one right here? What do you do first? Parentheses. So you do 6 divided by 3 minus 7 plus, and this is 4 over what? 2. Just kind of doing 2 at the same time. That's okay. What's 6 divided by 3?
How can you make the assumption that it's 4 over 2?
Because 1/2.
Over 1.
Nope, it's multiplication. Multiplying by half. Yep. So you end up with 2 plus 2 minus 7. What's 2 minus 7? So it's going to be negative.
10.
Negative. It's plus.
Oh.
Negative 3. Exactly. Any one operation in there, is it super challenging? Not really, but if you do it lazy or you're not too clear with your writing, what happens? So start with each piece. Literally just break it down. What does this become right there? What's negative 5 minus negative 8? 3. What's negative 9 minus negative 7?
Negative 2.
Negative 2. What's negative 1 minus 7? Negative 8. What about this right here? What's 12 minus negative 8? 20. What's 3 times 2 plus 4? 10. So what do you end up with? I'll change color here. We end up with negative 4 times 20 over 10 minus 5 times negative 8. All I'm doing is transcribing. Divided by what?
Oh, divided by
Negative 2
negative 6.
minus
Minus.
3. What's 20 over 10? So negative 4 times 2. What's negative 5 times negative 8? All over negative 5. What's 40 minus 8? Done. Leave it as an improper fraction. Totally down with that. Totally down. All you're doing is substituting in. So when you do these, make sure you substitute in the right place. So why don't you try these two right now. I'll make it bigger for you. There you go. So try that right there. Anybody get to here so far? You get negative 21 over 4 plus 9 halves all over 4. What's the best way to simplify this? Let me show you another tactic. You see the little side button on your pen? You've avoided it, right? If you hold it down, you can select a whole bunch of stuff and then move it. Make it bigger, make it smaller, do whatever you want with it. If you wanted to simplify that, does anybody know what like the all-star move for simplifying is? What do you want to do at that point? Anybody have a guess? What's a great thing to do? One thing I can multiply this by and not change its value. No, if I multiply by 2, it's 1. So you can multiply. How many different ways can you write 1? 2 over 2, 3 over 3. How about 4 over 4? Watch what happens. If I multiply this by 4, what happens when I multiply negative 21 over 4 by 4? What does it become? This becomes negative 21 plus 9. When I multiply the 4 by the 9 over 2, it turns into 18. And what does the denominator become? 4 times 4 is 16. What does this become? Negative 3 over 16. I love doing this. I don't like adding, I love multiplying by a form of 1. Why did I pick 4? Because it was the common denominator on the top. But what's 4 over 4 equal to? 1. Do I change the value of something if I multiply by 1? No. I like this.
Do you change it if it's negative 1?
What?
Is it? Yeah, it does, right? If
Changes
it's
it?
1?
Yeah. It would change the value. So you can't use negative 1. Negative 4 over 4. It has to be the same thing on the top and the bottom. This window right here, which is great, but this is cool because it's just in the browser. The thing is, I want this to come up in, she didn't write anything in it yet, so that's why it's blank. Look in the upper left here, you see edit in browser. Oh, you see open in OneNote up here? If I click open in OneNote, I'll have to sign in first. In the upper right, you have to sign in. It'll take a second, but it'll sign in. Once you're signed in and you click on open in OneNote, it will open it in your OneNote program. And then once it's in there, you don't have to do this again. Once it opens up in OneNote, you do